Okay, so now let's see another interesting topic. Sorry guys, I just dropped my phone. Okay, here we have the wind farm layout and wake effect. I just like this concept actually. It's like interesting. Like most of people don't know about this wake effect, but we'll see. Let's say here we have turbine A, we have turbine B, let's say as upstream and downstream. So there is a wind here, right? If we place this wind turbine B in the same direction or in the same direction like this, there is reduced wind speed. So like most of the wind, they will be blocked by this turbine A. So like it's gonna be a reduced wind will pass through this wind turbines into this. So we call this wake effect or reduced wind speed. Or turbine A receives reduced wind speed due to turbine B receives reduced wind speed due to turbine A. We call this reduced wind speed or wake. What does it mean? Turbine A disrupts downstream airflow through wake effects. This thing disrupts the downstream airflow through wake effects or through reduced wind speed. Then turbine A will have lower output due to wake. So when we are installing a turbine, we need to make sure this wake effect. So if we make this turbine B here, it's not gonna be effective. So we need to at least, let's say 45 degree here. Sorry, like this. Yeah, we have to put the wind turbine here. Yeah, so we're now going to have the wake effect, which is disrupting the airflow and then leading us to have a lower power output due to this effect. What are the challenges of wind energy? So let's see the challenge of wind energy. The first one is intermittency. The wind doesn't blow always, right? There are times where there is no wind. There are times where there is high amount of wind blowing. So this one is the first. Here we are trying to come up with energy storage systems, right? There are different kinds of energy storage systems. Like once the solar panel, what we call absorbs the heat from the solar, we need to make sure that it could be battery, it could be thermal energy storage systems, it could be rock or sand. We have to store that heat so we can use it when there is high demand, and we can store it when there is low demand. So this is the question still now. Intermittency. The second one is cost and competitiveness. Cost. It's obvious that, as I said before, in order to develop solar panels, it's kind of expensive. The same thing for wind energy. In order to have this giant 150 meter long wind turbines, it's kind of costly to develop them. Like it could be like the other day I remember I was watching how these wind turbines are fabricated, and it was a huge company, and they were like using hand lap method. They were using fiberglass and they were placing epoxy on top of the fiberglass. It was like almost 150 meter, which makes it too costly to develop these wind turbines. Not only that, their shipment also is an issue. In order to move them from the country where they are developed, let's say into Africa, it's kind of they are long. You're gonna use costly ships. So this is also a question. The what we call the cost question. And we have grid integration and transmission. The challenge of wind energy, as I said before, their intermittency, and in grid installation is also still a topic, as long as we don't have the effective or efficient energy storage systems. And the other one, environmental and social impacts. These are the challenges that still we're not coming up with the efficient wind energy or wind turbine that we need.